Ladies and gentlemen, good afternoon. I am very honored to present today this conference paper in the 11th International Conference on Optimization and Application ICOA 2025 titled Towards Secure Artificial Intelligence Systems, presented by me, Tarek Gmeh, a PhD student from the Laboratory of Artificial Intelligence, Data Science and Emerging Systems in the Sidi Mohammed bin Abdullah University of Fez, co-authored by Dr. Shayma Shqera and supervised by Professor Hakim Al-Fadali from the same laboratory. To begin our conference, let us emphasize the motivation of this research subject. So recent advancements in artificial intelligence technology bring great opportunities and challenges to organizations, including how AI can affect their cybersecurity capabilities and risks. The National Institute of Standards and Technology, NIST, recommends three focus areas related to bringing AI. First, cybersecurity of AI systems, our area of research, AI-enabled cyber attacks, and finally, AI-enabled cyber defense. In our research area, we believe that artificial intelligence systems are now part of critical infrastructures and information systems. They offer immense potential, but also bring novel vulnerabilities that attackers are already exploiting. Attackers are already exploiting AI in sophisticated ways with sometimes catastrophic consequences. This motivates the need for structured cybersecurity approach. Our study was guided by two central questions. First, how can we frame the threat landscape of AI systems? And second, how can we secure them? To answer these questions, we will start by framing the artificial intelligence systems to know what are we securing. Next, a systematic literature review will be detailed across major scientific databases, applying strict inclusion and exclusion criteria. Finally, we will focus on works dealing directly with cybersecurity of AI and go through discussions and recommendations. Before framing cyber threat, we will clarify in section 1 the scope of artificial intelligence systems. The American Mathematical Society, AMS, defines 13 AI subfields, ranging from general usage, learning and adaptive systems, pattern recognition and speech recognition, theorem proving, problem solving, logic in artificial intelligence, knowledge representation, languages and software systems, reasoning and their uncertainty, robotics, agent technology, machine vision and scene understanding, and finally, natural language processing. On the other hand, the Association for Computer Machinery, ACM, provides 8 subclasses for AI as follows. First, natural language processing, NLP, knowledge representation and reasoning, planning and scheduling, search methodology, control methods, philosophical and theoretical foundation of AI, distributed artificial intelligence, and finally, computer vision. In addition, we can find other fields in many references like Springer, where the fields are machine learning, computer vision, logic and reasoning, language and communication, and finally, agents and actions. By combining all those approaches, we adopted a 6 AI field subclasses. First, natural language processing, knowledge representation and reasoning, philosophical aspects, machine learning, computer visions, and agents and actions. Regarding the pillars of AI systems, many research works were consolidated to represent a complete IAS composed of first, objectives by defining the goals or tasks that an AI system is designated to achieve. Second, data. It is the vast amount of information that artificial intelligence system processes to learn and make decisions. Third, algorithms are the mathematical procedures or sets of rules that guide the artificial intelligence system in analyzing data and making prediction or decisions. Fourth, infrastructure, referring to the technical foundation required to build, deploy, and maintain AI systems. Fifth, measuring performance, reliability, and ethical alignment of IS against predefined objectives, meaning the evaluation. And finally, sixth, security and privacy, enhancing the security of AI system and protecting data from adversarial threats, ensuring compliance with legal and ethical standards for data confidentiality, integrity, availability, and user consent. By mapping the fields and pillars of AI systems, in Table 1, we consolidated a selection of relevant papers based on our AI system pillars application. For example, starting with NLP, we can clearly state that the objectives are designing systems to understand and generate human language. The data is the text corpora, annotated datasets. The algorithm used can be transformer architecture like BERT and GPT, sequence to sequence models. The infrastructure are the GPUs clusters for training LLMs, cloud APIs for deployment. For the evaluation, we can use metrics, blue for translation, rouge for enumeration, fairness audit for bias, and for security privacy, we found the GDPR compliance, anonymization, adversarial robustness against prompt injection, etc. So we have all the AI fields that were already done by our work and all the pillars for the artificial intelligence system. Now that we consolidated the scope of AI systems, let us emphasize a review of previous works based on the following. So we worked on the following publishers' databases, including IEEE Explore, Elsevier, Spring Links, Science Direct, and MDPI. The period was all time, and the chosen keywords were cybersecurity of AI, or cyberspace security of AI, or security of AI, or cybersecurity of ML, or security of ML. With the inclusion criteria are written in English. Full research paper focused primarily on the cybersecurity of AI. For the inclusion criteria are the following. We can say that cyber attacks on AI system help to think red, to act blue, and defend. To do so, many attacks frameworks can describe the adversary, like the Lockheed Martin cyber kill chain, the MITRE attack, adversarial tactics, techniques, and common knowledge, Diamond model, Mandiant's Google attack lifecycle, IBM X4 cyber attack preparation and execution framework, the unified kill chain, and some specialized frameworks like the MITRE Atlas, which is adversarial threat landscape for artificial intelligence systems. To describe the IAS threat landscape, we'll use the pillars already cited and specify for each pillar the attack vectors. In fact, as a state of the art, we found attacks on objectives, attacks on data, model extraction attacks, attacks on infrastructure, evaluation bias, and security and privacy attacks. Since our goal is to find an approach for securing AI, we suggest the following common three applied categories: process, technology, and people. For process, we find the EAAA Global Initiative on Ethics for Autonomous System and Intelligent System. We find also the NIST AI RMF, the ISO 42K1, and of course the certification of IEEE the certified. For the technology, we suggest technology security controls that are already existing, like using technical security controls set to IES, certified defenses, formal verification, AI software development lifecycle, and hardware level defenses. And finally, people for human security to use user-centric training, safe human AI interaction model, and cultural fairness norm. The next section will be dedicated for discussion and recommendation for future works. First, we notice a fragmentation of cybersecurity of AI system by addressing isolated AI components without adopting a system-wide view. Future work might consider AI system as interactive ecosystems. So researchers might adopt our six-pillar approach to develop holistic protection strategies. Second, there is a lack of standardized threat modeling for AI systems. So the recommendation is to standardize AI threat modeling framework to be formalized and validated across all AI deployment fields. Third, we notice insufficient evaluation metric for secure AI system because now we are just focusing on model accuracy or robustness but not including system level risk indicator. So in the future, securing AI system evaluation standards have to be beyond performance metric to include explainability, bias audit, attack surface analysis, and continuous monitoring tools. Finally, the gap in real-world validation due to verification through simulated or idealized environment will be addressed through conducting empirical studies that validate AI cybersecurity approaches in operational context across sectors. To summarize, artificial intelligence systems bring transformative opportunities but also expose an expanding adversarial attack surface. Our work framing the AI system through 6 pillars and mapped threats across fields. We showed that securing AI systems demands a multidisciplinary effort combining governance and certification processes, robust technical defenses, and human-centered safeguards. Looking forward, progress requires dynamic, real-time protections, cross-layered security analysis, and alignment of regulatory and technical standards to ensure trustworthy and resilient systems. Thank you for giving me this chance to be part of this great community. I will be more than pleased to answer any question and open to all your recommendations.